Welcome to this lesson on creating your own string library. As you've learned, C programs make extensive use of character strings, and the C standard library provides a series of string manipulation routines that your programs can use, such as string copy or string length. In this lesson, you'll learn how to create those functions yourselves. In a lot of cases, we'll use pointers, so this will be one of your first good hands-on exercises with pointers. Let's go ahead and get started. This program creates a function called string length that returns the number of characters in the string. The function is defined to return a type int, the number of characters. You can see that it returns or receives one parameter, a pointer to a character string. We've used the const keyword to indicate that our function is not going to change the string, but rather it's just going to loop through it, counting. Within our function, we declare the variable I. It's going to be our counter. It's going to keep track of how many characters we've seen. We then use a while loop to look at the value that's pointed to by the string pointer to see if it's null. Remember, C represents the null character as 0, and so when it points to the null character, it will be 0, so that'll cause our loop to end. If the character is not null, we increment our counter and look at the next character. And then we increment our counter and look at the next character until we find null. When we finally find the null character, we return our counter. When we run this program from within main, we're going to declare two string variables, one called string1 and one called string2. You can see I've initialized the strings to hello and hello world. When we run this program, we'll see the following output. And sure enough, we've gotten the right number of characters. This program implements a function called string copy. You can see that the function returns a pointer to a character string. That's because we're going to do the copy and return a pointer to the start of that string so the program can use it in a function call or to use it to initialize a string. And so in this case, we're getting two parameters, the source string that we want to copy from and the destination string that we want to copy to. Our function is going to save that destination string address. And so it's declaring a pointer to a character, and it's going to save the destination address so we can later return it after we've done our copy. Our copy uses a while loop. And within the while loop, it's doing an assignment. It's assigning the value that's currently pointed to by the destination string, the value that's pointed to by the source string. When it finally loops through all the characters, it will assign the null value, the very last character in the source string, to the destination. C will test the result of that assignment. It's null or 0, which causes our loop to end, and will return that address to the start of the destination string that we previously saved. So if we run this program in main, you can see that we create a variable called first name and initialize it to Chris. And then we create a variable called copy that's going to get our copy of the name. We call our string copy function, passing first name and our destination copy, and when we print it out, we should see that copy has the value Chris. Let's run the program. And sure enough, it does. And so anytime you're doing string operations, you need to keep buffer overflow in mind. In this case, we created arrays of the same size, so it's unlikely that we would overwrite contents. But had we created copy smaller, then it's possible that a buffer overflow error can occur. So as long as you keep that in mind and allocate your arrays correctly, you should be fine. This program creates a similar function called string append, which appends the contents of one string to another. You can see that the function returns a pointer to a character string. Within the function, we first save the address of our destination string so we can return it, so functions or programs can use it just as they would. They could call from within printf or something, and they'll have that starting address. So what we want to do is first find the end of our first string. That's the string we're going to be appending to. So we have a while loop that just looks at the value that's being pointed to within that string. And as long as it's not null, we keep looping through the string until we find that null character. Once we've found null, our loop will end, and we can start appending characters. And to append a character, we just assign the value that's pointed to by the destination string, the value that's pointed to by the source string. And then we increment the pointers to point to the next character. And we'll do this until we finally assign the null character, which is the end of our source string, to our destination, because we want both to be terminated with null. Our loop will end and we'll return the address of that destination string. Within main, we've got two strings defined. The first has the string hello with a comma and a space, and the second has world. We'll then call our string append to a string to contents of string 2 to string 1. When we print it, we should see the hello world message, and sure enough we do. And again, anytime you're working with strings, just keep your buffer overflow in mind. Now there may be times where you just want to append a certain number of characters from a second string to a first string. And so in this case, we've defined a function called string append end that gets three parameters: the string we're appending to, the string we're appending from, and the number of characters that we want to append. So we start out and we save, again, the address of our destination string. We're going to return it. And then we declare a variable I that we're going to use in our second loop. But first we want to find the end of that destination string so we can start to append characters to it. So that while loop just loops until we find the null character, which marks the last character in the string, and then we're ready to append. Our second while loop does two things. One, it's going to check, have we appended n characters? If they told us to append 5 characters, is I still less than 5? And is the value that's been assigned from the append operation not null? And so we might be appending 10 characters, but there's only 3 characters to append, so we have to test for both. If we get to the point that we've not assigned null, but we've hit our number of characters, so I is greater than n, we append a null character because we need to mark the end of that string, and we return our destination. So within main, again, we've got our two strings. One says hello comma world, or hello comma with a space, and the second says world. And we want to append the first 3 characters of that world string. So when we run this program, sure enough, we see hello world. A common operation we'll perform in our programs is determining if 2 strings are equal. And so in this case, we've defined the function strings equal. They receive 2 character strings, string 1 and string 2, and it's going to loop through the strings, just comparing them. Are the characters pointed to by each still the same? It also tests to see, have we reached the end of string 1? And so if we've reached the end of string 1, we can test, is string 1 null? And if string 2 is also null, then we've made it through comparing both of them, and they were the same, and they're both at the end, so we're going to return the value 1 to say strings were equal. Otherwise, we'll return to 0 that says strings weren't equal. Within our main program, we've defined 3 strings, string 1, string 2, string 3. Our first if statement compares strings 1 and 2, and if they're the same, it prints a message. Our second if statement compares strings 2 and 3. You can see they're different. One says hello world, one says hello mundo. So when we run this program, we see the message that strings 1 and string 2 are the same. We don't see the third message because that if statement failed because the strings were different. So depending on the processing your program performs, there may be times when you want to convert a string to all uppercase or all lowercase. And this program defines 2 functions, string upper and string lower. The first, string upper, converts a string to uppercase. And again, it starts by saving the address of the original string, and it prints it so we can see it. And then it loops through the strings looking at each one of the characters. And if the character currently being pointed to is uppercase, is lowercase, then it's going to be greater than or equal to a lowercase a, and it's going to be less than or equal to a lowercase z. We convert it to uppercase. To understand the conversion, you need to look at an ASCII chart to see the numeric values of the lowercase a and the uppercase a. And so it turns out that they're a fixed distance apart, and so we can use that distance to convert our strings to uppercase. And then we just continue to loop through each character looking if it's lowercase, convert it until we get to the end and we return the original string. Likewise, the string lower function does just the opposite processing. It loops through the string looking to see, is this character uppercase? So it would be greater than or equal to A, and it would be less than or equal to Z. If it is, it converts it to lowercase. With our main program, we declare the string hello world. And we then call string upper to display it and string lower to convert it to lowercase. So let's go ahead and run this. And sure enough, we see our original string. We convert it to uppercase, and then later we convert it to lowercase. Performs, there may be times when you want to find a specific character within a string. And the string character function allows us to do just that. It returns a pointer to the first occurrence of a character within a string. It gets a character string parameter and the character we're looking for. And the program just simply loops, looking through the string, seeing does the current character match the letter. And it will do that while the string is not pointing to null. And so we'll just look at the first character, the second character. Once we've made it through the entire character, or we've found a match, we return the address of the current character, or we return the null value if it's not found. Within our program, we declare the string hello world. We then look to see what's the first occurrence of the letter L. We call our string character function, and it returns a pointer. If it found that character, the pointer is going to point to the character. If it didn't find it, the pointer will be null. So our test, if pointer, is saying if it's not null, then we found it. And we're displaying the location of that character within string. And we're displaying an index. The way we get the index is to take that pointer location and subtract the address of our first string. And that will give us the offset. If we found it at the first character, the offset would be 0. If we found it at the second character, the offset would be 1. We then do the same processing to check for, does the string contain the letter M? Let's go ahead and run this. And it tells us it found the letter L at offset 2. That makes sense. Offset 0 has H, offset 1 has E, offset 2 has the letter L. Then it tells us it did not find the letter M. There may be times, depending on what our program does, where we want to find the rightmost or the last occurrence of a letter within a string. And so in this case, we can use the string character R for rightmost. We're getting a character string pointer. We're getting the letter that we're looking for. And we're starting off and we're saying that the pointer that we're going to use to move through our string is null. So we haven't found it yet. And then we're going to loop through our string. If we find the letter, we're going to assign our pointer to point at that current location of the letter. And then we're going to keep looping through the string. And so when we're done, we can return the value of that pointer. If we found it, it's going to point to the address of the rightmost occurrence. If we didn't, because we initialized it to null, it's going to return null. So within our program, we can look for the rightmost occurrence. When we run our program, it says it found L at offset 10, and it did not find M in hello world. And sure enough, if we look at our hello world string, the letter L appears in the word world at offset 10. There may be times when we want to know the number of times a character appears within a string. In this case, we've defined a function, character count, that returns a value of type int, the count of a number of occurrences. It gets a pointer to a string, and it gets the letter we're looking for. It initializes count to 0, we've not seen it yet, and then it starts looping through the string. Each time it finds the letter, it increments the count, and then it returns the count. And so if we run this program, in main we're got our string hello world. We first look for the letter L, and it will display a count of the number of times L occurred. And then we look for the letter M, and it will display a count of the number of times M occurs. And sure enough, it tells us the letter L occurs 3 times, which it does, and the letter M does not occur. In addition to determining if strings are equal, there may be times when we want to compare them. Maybe we're sorting an array of character strings, for example, and we want to know which one's less, equal, or greater than. And so the function string compare gets 2 pointers to character strings, and then it loops through them to see if they're equal, and the loop will end if we get to the end of string 1. And so we just simply loop through, and then once our loop ends, we say, does the character pointed to by string 1 equal the character pointed to string 2? And we've found the end of string 1. If that's the case, the strings are equal, return the value 0. However, if character or string 1 is still pointing at characters and string 2 is encountered null, then we know that string 1 is longer, so we return the value 1. Likewise, if string 2 still has characters and string 1 is null, string 2 is longer, so we return the value -1. Let's go ahead and run this and see how we'd use it. We've got multiple strings in our main program that we're comparing. And you can see that it says hello world and hello world are the same. Hello world and hello world with an exclamation mark returns -1 because string 1 is shorter. And then hello world and hello world returns 1 because string 2 is lowercase and is considered greater. Often we'll want to test whether or not one string contains a substring. And to do so, we can create the substring function, which returns a pointer to a character string. It receives 2 parameters, a pointer to a character string and a substring. And it's got 3 variables it's going to use as it loops through the strings. And so essentially, we're going to start at the beginning of the string and say, does it equal the substring? No. Well, increment character, does that mark the end of the beginning of the substring? No. Look at the next character. Until we finally start matching characters. And we're going to use our index variables, I, J, and K, as part of that comparison process. When we finally find the substring, we're going to return a pointer to where it begins. If we never find it, we're going to return the null value. And so let's look at an example. Within main, we're declaring our string to have the contents hello world. We're then looking to see, does that string contain the substring world? If it does, it displays the index location where it starts. It then looks to see, does the substring contain an exclamation mark? If it does, it displays the index location where it starts. And finally, we check for Mundo. Let's go ahead and run this. And it says it found world at offset 7. It found the exclamation mark at offset 12, but it didn't find Mundo. There may be times when you want to remove a substring from a string. And so our function remove substring does just that. It gets a character string and the substring that we want to remove. And we're going to loop through the string, much like we did when we were searching for a substring, to see if we found the substring. So we have a variable called location. We initialize it to -1. And if when we get through our loop, location is still -1, we didn't find the substring. But if it isn't -1, then we're going to modify our string to remove the characters of the substring. And when we're done, we're going to return the string. So let's see how this works. In main, we've got 2 strings defined. Both are hello world. And we're calling remove substring the first time to remove the world exclamation mark. The second time we call it, we're trying to remove world in all uppercase. It's a substring that doesn't exist. And the third time, we're just removing the exclamation mark. When we run this program, we see that hello world minus world with an exclamation mark yields hello comma. And hello world without world, a substring that wasn't found, leaves the original string. And finally, hello world removing the exclamation mark yields hello world. And so we did the last one. It's important that when you're doing string manipulation that you kind of test your borders or your boundaries. The first character in the string, try removing just it. The last character in the string, try removing that just it. So that's why we ran this program with the exclamation mark. It allows us to do some testing. And so our previous program removed a substring from a string, but there may be times where we want to remove every occurrence of that substring from a string. And so I made a slight modification to our previous program down at the bottom that says, if we found it, call remove substring again to get the next occurrence. And so we created a recursive function. So it's going to continue to call itself as long as the substring was found. And when we're finally done, we return the string. And so we talked about recursion in our lesson on functions. And so this is a case where we pass the substring that we want to be removed. And so we remove it, but we check again by calling the function to see, can we remove another one? Can we remove yet another one? And so this allows us to remove each occurrence. And so in this case, we're going to, within main, define our hello world string. And then we're going to call remove substring to remove world. We're going to call remove substring on string 2 to remove the else. So that will cause a recursive series of invocations. And then we'll do it one last time to remove the exclamation mark. And so we run our program. And sure enough, we see that we've removed hello world. We removed all the L's in hello and world. And then we removed the exclamation mark. So our recursive call worked. Finally, there may be times where you want to replace one substring with another. And our function replace substring does just that. It has a string, it has the old substring that we want to find and replace, and it has the new substring. And so our processing is similar. We're going to loop through our string to see, did we find the substring? And if we found it, our location variable is not going to be -1. And so we'll then replace the characters in that substring with the new substring. And then finally, we're going to do that by building a temporary string that we copy characters to. And when we're finally done, we copy that temporary string back to our string, which we return. And so in our main program, we've got multiple strings being defined, string 1, or string 2, and string 3. And then we're calling replace substring the first time to replace world with an uppercase world, to try to replace mundo with world, but it doesn't exist in that string. And then we're going to do it again, and then we're going to replace the hello comma with a null string that just eliminates it. So when we run this program, let's look at our output. So hello world replacing world with uppercase world yields hello uppercase world. Hello world replacing mundo isn't found, so our string's the same. We do again another replacement of the uppercase world, and then replacing hello world with the hello and hello world with the null just returns world. So what will you learn next? C programs use variables to store data as they execute. A variable normally stores one value of a specific type. You have learned that using arrays, a variable can store multiple values of the same type. In the next lesson, you'll learn that using a structure in C, you can create a variable that can hold multiple values of different types. In this case, we have a structure of type employee. It has a name, an age, and a salary. And we can declare a variable of that structure called worker. To access the individual values within the structure, we use something called the dot operator. So we can assign the employee age 50, the employee salary 100,000. And so in the next lesson, we'll drill deep into how you work with structures.